The next speaker and our last speaker, is Alan Clark. Alan is the Director of Transportation and Air Quality Programs for the Houston-Galveston area. Council is also the Director for the Houston-Galveston area, metropolitan area, on the planning organization of transportation. He holds a master's degree in civil engineering and on city and regional planning from Ohio State University. He's also an adjunct, at the Texas Southern University. If one has lived, kind of through transportation problem, prior, to retire, I'm not sure if I would like to have, your position here in Houston. But it's really a pleasure to have you tonight.
The great advantage of being the last speaker is that half of your slides have already been presented, so you don't have to spend nearly as much time talking as you had hoped. And in fact, that is just fine with me, because not being a climate scientist of any kind, and having been in two recent studies, one I'm going to talk about today, which we were calling the Gulf Coast study, the climate effects on the Gulf Coast region, and a second, which is really looking at how we should think about the effects of and potential for climate change as we plan transportation facilities. I've been thinking a lot about the information that's becoming available to us, and what does it tell us? How do we incorporate this information in our decisions? Every day, our policymakers are making many decisions on investment and infrastructure. Some of those are short-term investments, repaving a road somewhere. But many of them will be decisions which affect our community not only for 20 years or 30 years, but for 50 to 100 years. And certainly we need to understand how climate change should be incorporated into that decision making. I'll talk a little bit about that, and I will ask for your indulgence as I speed through a lot of different slides. First thing I wanted to touch on is that many of the effects of climate change have already been with us, and they affect the area of transportation in some ways that we haven't talked about. I'm not going to go into this in any detail. I'd encourage you to look at the Gulf Coast study. It's on the U.S. Department of Transportation's website if you'd like to do that. But climate change can affect the maintenance practices that we need to employ, especially increased maintenance on structures. It can change the materials that we use in the future, as some materials are significantly less durable and more susceptible when we have higher temperatures. Certainly the storm activity can be very destructive on our infrastructure, but the changes in rainfall and the intensity of it can have many effects. Those who are in the highway side of transportation worry all the time about bridge footings and the potential for water scour to undermine the integrity of bridge structures. So if as Dr. Bedient was describing, we see not necessarily a large increase in total rainfall, but an increase in the frequency of more intense rainfall activity, it can have a very negative effect on a lot of our bridge structures that cross waterways in our region. And then precipitation and runoff are, of course, a major issue in our community. Everybody who I talk to about transportation, you generally talk about two things, flooding and congestion, and which one comes out first depends on what part of town you live in. But they're both very large issues. And again, if the patterns of precipitation change, it would change the way in which we need to modify our transportation facilities and build new ones to be able to make sure they can operate effectively during these times and safely during these times, and so that they aren't contributors to unwanted additional flooding in our communities. Maybe I should sit down now because that was most of what I wanted to tell you, but I'm going to feel inevitable to show you just a few things. First of all, transportation is a very major part of our region's economy. Our Gulf Coast study looked all the way from New Orleans to Houston. What we began to do as we thought about how to address climate change was first to say, well, what are our vulnerable facilities? What would we expect to be affected by the climate change conditions that I just mentioned, temperature change, sea level rise, increased storm activity, etc. In this area on the map, the principal roadways shown transport some 85 billion vehicle miles of travel per year. Just in the Houston region, the daily vehicle miles of travel are over 200 million. So you could go to the sun and back again in your car, your SUV, I guess, if you were the only one driving in Houston. Of course, that's not all that goes on in transportation in this region. It's one of the country's major port areas, not only here in Houston, but of course along the Mississippi River and other parts of the Gulf Coast. Something in the order of a quarter of the water tonnage for the United States moves through the ports along the Gulf Coast. This is sort of a zoom in on some of ours. Remember, the Port of Houston is not one thing, it's many things along the Houston Ship Channel. We're used to thinking of the public facilities, and we have many port facilities just in our region. Of course, not everything that gets here moves on the highways. A lot of our movement is through shipping, and this is just showing one aspect of shipping. This particular slide is looking at goods that are moving through the port of New Orleans out to or from the rest of the country. The reason that's spread all across the country is because the Mississippi River is a major transportation corridor for all kinds of agricultural products. And then, of course, railroads. Railroads are on the city of Houston's seal. It was home to many railroads when it was founded in the early days, but also we are one of only 4 transition points for freight rail from the major West Coast carriers to the major East Coast carriers. This slide says the obvious, I guess. I mean, I can understand slides like this. All this red says these are the areas that are really low. And we know that this area is really low. And by low, you can see on this slide, and you'll see in the subsequent ones, these are the areas that are very susceptible to any change in sea level rise, to storm surge, and other increases in precipitation activity of that nature. Now, in our immediate area, we don't have a lot of highways, for example, on this slide, that would be inundated at only a 2-foot level change in sea level. But we have a number, and they're quite important if you happen to live down in Surfside or over in Galveston or in the Beaumont area. However, if we look at a 4-foot level of sea level rise, you can see that becomes much more significant, goes up the Gulf Freeway, takes in the Clear Lake, part of the Clear Lake area. Interstate 10 is vastly affected, and if I continued this map towards New Orleans, you'd see that almost all that road infrastructure is susceptible at that level change. But rising sea level is only one aspect of things. Rising sea level contributes to storm surge activity, to wave action, and here you see the US 90 bridge, and I'm sure you all have seen these pictures in the New Orleans area after Katrina. There's a little bit of a close-up. You know, with these storm surges, you wonder about the power behind those. It just treats this concrete like it was so many Tinker Toys. When we look at storm surge, our risk and our exposure is much, much greater. This is a storm surge of 18 feet, and Dr. Obedient just reminded me that 18 feet isn't even sort of a middling thing anymore in terms of storm surge. Highways are at risk, but rail lines are as well. Again, not as much in the Houston area, although there are some important ones serving, like, for example, the Port of Galveston, the Port of Freeport, and Beaumont, but particularly as you again go east towards New Orleans, many of them are endangered. Can
I just say one thing?
Yes.
for our energy audience? We're now putting ethanol into all of our gasoline, and the vast majority of that ethanol moves through the rail system. So any supplies of gasoline that are coming, and you have an east-west interchange, it's all having to move through these railroads. So you'd have the disruption of the ability to put ethanol in gasoline also. Just mention that.
Even at a moderate level, or maybe I shouldn't call it moderate, but even at a level of at a sea level rise of 2 to 4 feet, it would have a negative impact on almost all of our region's port facilities. And of course, the same would be true if we were talking, even much more so, were we talking about storm surge. And this graph actually shows you sort of the storm surge areas between, from 18 feet and then 18 to 23 feet. Those don't look dramatically different, but believe me, all those port facilities are well underwater. And then, I couldn't pretend to be an engineer without showing you one very complicated slide that you probably can't figure out. That's what this one's all about. Yeah, it is a good slide. Yeah, I mean, it's truly terrible. But one of the things that one of the ways to think about temperature change is not so much the averages, but what are the extremes. And you heard that from both of our speakers tonight. And I thought this was a good slide to give you an idea of what we're talking about. This, again, came from the Gulf Coast study. And what you see on this slide, first of all, our current conditions. This is the year that's shown in the blue, 2007. And on the left is probability. Have to work that in somewhere. I never understood probability, but I guess I should go to maybe Vegas and figure it out. And over here you can see that there's a sort of an 80% chance. And then if you look at the bottom, those are days, and this happens to be when we would have a temperature of about 100 degrees. So there's sort of an 80 plus, well, really closer to 85 or 90% chance that we would have at least 100-degree day in a year. This was in 2007. And that you can kind of understand that, although I tell people it almost never gets to 100 here because once it gets past 95, it rains. I don't think the atmosphere can hold that water at that point. Well, anyway, as you look across the days, the number of days of over 100 degrees, you can see that, wow, the chances of us having 18, 19, or 20 days of 100-degree temperatures are very low, almost non-existent. Then, as you look at the different colored bars, you're going forward in time. So as you look at the green bar, that's 25 years from now. The red bar, 50 years from now. The black bars, 100 years from now. So let's go out 25 years. You can see that now the chance of having 20, 18, 15, 16 days of 100-degree heat are no longer zero. In fact, if you go to about 50% probability, we could have maybe 8 days of 100 degrees temperature. And then we go out another 50 years, you can see at about 50% chance. Let's see, this is the next one. That makes a big jump when you go out to the red bars, which are 50 years. Of the 50% line, let's find that. Well, we're almost out here at the 20 day mark. So increasing temperature in terms of severity is one of the things that we have to think about, and it's particularly important to transportation people. Why? Because things fall apart when they get real hot. Even our railroad tracks will require different types of construction and maintenance if we see temperatures at this level, because they will become they will weaken, they will bend, they will come apart at the joints. Same thing happens with our pavements, because they expand and contract in these temperatures. And on bridge structures, the things that hold those bridge decks to those columns, we call them the bridge joints, will be very adversely affected by this and may require early replacement. So that's going to cost us all a lot of money at a minimum. Now, how do we deal with this? And this is what we're beginning to wrestle with. How do we understand, first of all, what we're vulnerable to? So we're looking at what would be affected by these temperature changes, what would be affected by changes in sea level. And there are different kinds of things that we can do. One set of strategies are what we call operational approaches. And an operational approach is one of the things that Dr. Bedient is working on and has been doing in our area very successfully. He's helping us to understand when it is, what the likelihood of having flood events in our area are before we actually flood the highways. I mean, now you learn about it when you're driving out the freeway and you turn on the radio because you're stuck in traffic and you hear that some stream flooded and your road is closed. But you have to just sit there or try to find high ground. Dr. Bedian is using precision radar to anticipate what the rainfall activity is going to be, how that will affect the streams in the region, and where it might cause flooding. So an operational measure will help us to anticipate how our transportation system will be affected and give the users information. And the earlier and the more information we can give you, the more choices that you have. Because you can decide, hey, I'm not going to go to that shopping mall, I'll go to a different one. Or I'm not going to go today, I'm just going to stay home. Or maybe instead of driving, I'll get Fred down the street who has one of those real high pickup trucks to take me. So your choices become different. Design standards. Certainly we will be considering building things differently than we have built them in the past. However, that's a very expensive decision, and I'll talk about in a little bit more how we should think about these higher levels of investment. And then I think the other part is we've got to think about the very basics. We're here because we have access to key natural resources, the Port of Houston, for example, the oil and gas industry that was founded here. But how we grow in the future really has a lot less to do with those historical precedents. At HGAC, we have a long-range forecast, which for us is 35 years, not nearly long-range enough. But we have run alternative scenarios that allow the policymakers to ask questions, such as, well, let's assume that in 10 years, we're no longer going to allow development in areas today that are prone to flooding. How much would that change things? And what if that additional growth went into parts of our community that were well served by mass transit and was of a mixed-use development that allowed greater access to activities by walking or public transportation? We found that with the same investment in transportation facilities, a small change in how we develop could reduce the vehicle miles of travel in the future by almost 10%. So that was very interesting information for our policymakers. And I think we have to link these decisions about development and transportation together. Okay, now here's the hard part. I've spent my whole life telling engineers and policymakers I knew exactly what was going to happen 20 to 30 years from now. I only ever gave them one number. Sometimes they asked me for decimal points. One time I was asked for numbers on turning movements at an intersection 20 years from now. And I said, what are they going to do with that information? Unfortunately, I had it and I gave it to them. All I'm saying is that we are used to thinking about point estimates of the future and not about ranges. And every speaker that preceded me showed you lots of information about ranges. So we have to start talking about scenarios and about ranges of outcomes and how we make decisions under those circumstances. One of my problems is that even though many are surprised to learn that someone is thinking about our transportation needs 30 years from now, that's too short of a time. The climate change effects that we talked about, although they're happening today, they're going to happen over a very long time period. Even if we all stopped driving today, we'd still see a lot of impact from all of the carbon that's been released into the atmosphere already. So there's a mismatch between our planning and thinking about the future and climate. So what do we do about it? How can we begin to address it? One thing I'm trying to understand how to use are some tools that are used in other disciplines. One is risk management. And if you can think about it this way, we have facilities that are very important. We have facilities that, yeah, they're important to somebody, but if we were to lose the ability to use them, at least on a short time period, we could have alternatives to them. Or they could be repaired or replaced relatively easily. So going up, we have a dimension of risk. And if a facility is not very important, even though it's likely to be affected by climate change, it may not be too important for us to do things dramatically different because we can just replace it, or we have alternatives. On the right-hand dimension, we have those facilities which are really important. Let's say we're talking about the Causeway Bridge onto Galveston Island. That's essentially it for getting there, unless you're going to take that ferry. I imagine we can't evacuate 50 or 60,000 people on those little ferries very quickly. So that's a really critical facility. But if it's not endangered, then again, we may not need to worry about it. What we do need to worry about are those things that are really important that are at risk. And so one of the things that the Gulf Coast study did and that we are trying to follow up on is to identify where are the really important facilities that are at high risk. Those are the ones we need to give attention to. And then how do we do that? Well, what this graph is talking about is sort of our risk assessment. In other words, where are we exposed? What are the vulnerable facilities? To what extent do they have resilience? In other words, can we repair them quickly? Can we replace them quickly? Or do they take a long time to fix? And then what do we do about it? Can we protect that facility? Can we design it in a way that it can better accommodate the changing climate? Or do we simply need to say, folks, we've got to put this somewhere else. This is a bad place to be, and therefore we need to think about other kinds of alternatives. Well, this little formula, I guess, was for all those students. Where are they sitting? It's a simple-sounding concept, but I put this on here because this is really hard to do. It's hard to get information that tells you in some quantitative way how to measure the risk and exposure that you have. And transportation people are not used to doing this. So for the first time, we're kind of talking to some of the climate folks to try to understand some of this. Let's see. I think I'm about at the end of these things, and there are some simple things that we're trying to do. We're trying to extend our thinking about the future in terms of time, and so we can better understand these impacts. We're trying to link our decisions carefully to the ideas about growth and development that will help our area be more sustainable, less dependent on for example, auto travel. And then we've got a lot of information we need to put together that help us understand where we're vulnerable and where our risks are. And we're still struggling to understand climate change. You saw lots of graphs that had lots of ranges. And if I were to bring in one of my engineer friends from the state DOT, they'd say, well, wait a minute. Don't tell me it's between 2 feet and 10 feet. I need to know that it's 5.3 feet or whatever. Because they want to, we do not reward people for over-designing and overbuilding facilities because we've not defined the problem in that way or defined the risk in that way. Let's see. Well, we didn't talk too much about that, but I am concerned that when you look at these historic graphs of climate change, they don't happen in 0.03 millimeters per year. They happen in ragged jumps. And I think we do need to be prepared and that climate change can be sudden, not gradual. And again, this leads us to thinking about strategies like, do we adapt facilities or do we wait till they get destroyed and then we replace them in a completely different way or a different place? These are, again, some of the thoughts that we have about how we might deal with it. I apologize for being the last one, and hopefully that showed you too many slides in duplicate, but it's certainly my privilege to be here.